In Module 2, Exercise 3, again, we're asked to look for whether these statements are true or false. So we'll pause the tape again, give you a chance to look them over, and we also want a why. Looking these over, you can check your answer. Here we had 4 false and 4 true. Now looking at the false, here it's x to the 4th, x to the 2nd. So where 5x is a factor of each one of these, it's not the largest common factor. The largest common factor of these two terms would be 5x to the 2nd. Again, you have to take out the greatest or largest common factor. And this one, if your degree of the equation is, let's say, a 7, you may only be able to take out a 2, an exponent of 2 in each term. So that's not true. Now, as you look at 3, this is prime because you can only factor out a 1 from these. So if that's all you can factor out, then it's prime. And this one's kind of wordy, but it says when your leading coefficient, like a negative 4x to the 5th, and then you have others, you often can take out a negative, let's say negative 4x to the 2nd, and then here you're left with a positive x to the 3rd. So you're left with something in the parentheses that's the leading term now is positive. You did so by factoring out the negative, so that's true. In number 5, it's not prime if it contains a common factor other than a 1 or a negative 1. We said up here it's prime, and we could have also taken a negative 1 out of here. That would have made both of these negative if we did it that way. Now, when we have 4 terms, we consider factoring it by grouping. So not all, but some of the polynomials with 4 terms can be factored by grouping. Here they're saying all. That's what makes it false. Now as we look at this expression, and this expression, these are all equivalent. Here we reverse them, took out a negative, and actually taking a negative out of these two and then putting them alphabetically is what this is. So if you were to multiply this, this would become a negative a and a positive b, which is what we have here. And you could also put a 1 there sometimes, and that's what this is. So these are all equivalent. Now as we look at example 8, we say the complete factorization of this. When you look inside the parentheses and you see you could still factor out an x here, then you haven't completely factored this expression. There's still an x that could have been factored out of there. Alright, let's go on. We're going to take a look at some of these others too that are easy to do. And renewing our lesson, we talked about finding the zeros. So these are quadratic equations that we can put into our calculators and graph them, and they look like this on a graph. Now remember, this is your y-axis. This is your x-axis. Well, when we find the zeros, and I think I could raise that up just a little bit. There we go. When we find the zeros, what we're doing is seeing where the parabola crosses the x-axis. Because what is the value of y when these lines cross the x-axis? Well, y here is 0. So in finding the zeros, we're looking for here -2, 0. That would be this point. And here, it's actually going through the origin, which is 0, 0. So when your y value is 0, then that is the x value when we are finding the zeros of a function. So it's easy to sort of pick them up right from the graph. So there it's going to be a -1, 0. That's this 0 right here. And the other one is going to be a 3, 0. So when we're finding the zeros. Now, it says use the graph below to solve if your equation is this: x to the second plus 2x equals 3. Well, we look right here where g of x is 3, which is right there. So what would be your solutions there? Well, it would be there and there. So what are your points? Here it's -3, and our value there is 3. And then for this one, it's going to be a x value of 1 and our y value of 3. So that's some modification. Here we're finding the zeros. Here they're asking us to find another value where this equals 3. And that's what we've done using the graph. Okay, you'll be doing your practice and your quiz-mes as you go toward your mastery, and we will continue.